Assalamu alaikum warahmatullahi wabarakatuh. This is our third presentation on fundamentals of structural mechanics. We will solve two examples today. The first example, considering the truss shown, if the maximum allowable stress is 300 megapascal, all members have a pipe cross section as shown with an outer diameter of 100 millimeter and a thickness of 2 millimeters. What is the maximum allowable load P that will cause member BC to remain safe? So, section above, if we take a section above A and B as shown by the red dashed line, both A and B, sorry, if we look at the dashed red line, if we take sigma moment about A equals 0, we will see that 3 times FBC minus 12P equals 0. So therefore, FBC is equal to 4P. So this is the relation that we will depend on. Then we'll go and calculate the capacity of FBC. So the area of the cross-sectional area of member BC is equal to pi times the outer radius square minus the inner radius square. So pi times 50 square minus 48 square. So this is equal to 615.75 millimeters square. The capacity of the member BC is equal to this area multiplied by the sigma allowable, which is 300. So this will give us 184.7 kilonewton. So the maximum allowable load is simply this maximum allowable force, the capacity, divided by 4. So this is equal to 46.18 kilonewton using the relationship above between FBC and 4P. Going on to the second example, considering the frame shown, it is to carry the load shown, knowing that the allowable normal stress for that steel is 160 megapascal, select the wide T shape that should be used. So if we go and look at the bending moment, if we draw the bending moment diagram, if we take a section just to the right of C, we will see 2 times 5 times 2.5, which is 25 kilonewton meter. If we take a section just to the left of C, we will see 1 times 5 times 2.5, so this is negative 12.5 kilonewton meter. So the difference between them will be in the column, will be shown as a bending moment in the column AC, which will be minus 12.5 kilonewton meter. However, if we look at the normal force diagram, the normal force in BC and CD is 0. However, the normal force in AC is the summation of all of the vertical forces, which is 1 times 5 plus 2 times 5. So this is negative 15 kilonewton. So in such a case, we understand that the maximum bending moment and the maximum axial force do not occur together at the same location. ما بيحصلوش مع بعض في نفس الممبر. So for member CD, the one having the maximum moment of negative 25 kilonewton meter, the normal force is equal to 0. So S minimum is simply the minimum section modulus that we need will be that maximum moment, of course after unit conversion in Newton millimeter, which will be 25 million Newton millimeter, divided by 160. So this will give us 156 to 150 millimeter cube. So going back to the properties of these WT sections, we will look at the most suitable WT section. So we have the most suitable is one of three, the 169, so WT 180 by 108, WT 180 by 98, WT 180 by 89.5. The most suitable of them is the WT 180 by 98 because S is 157,000 which is just above the minimum. So it is an economic alternative and it still could withstand that load. However, we need to make a check concerning member AC, especially that the same size will be used for the three members.